guys. Okay, so to help give a little bit more clarity on how you can determine whether there's more than one triangle, I set up 3 different problems, all of which could potentially have 2 triangles. So they could each have either 2 triangles, 1 triangle, or no triangles that match the information that's given. So we're going to go through and try to investigate each one. And the first one, we have beta equal to 80 degrees, b equal to 7, and a equal to 5. So the first thing we would try to find is alpha, which is what we're asked to find anyway. It would be sine of 80 degrees divided by 7 equals sine of alpha divided by 5. And then we can cross multiply. So we get 5 sine of 80 degrees equals 7 sine of alpha, divide by 7, sine alpha is approximately, let's go ahead and type this in, my calculator, uh-oh. Okay, typing this in, 5 sine 80 divided by 7 is 0.7034. Okay, so then to solve for alpha, we'll take the arc sine of that. When you type in your calculator, you want to use the whole entire number. So arc sine, and then go up and pull that number down. And you get 44.7 approximately. Okay, so we have one answer for sure for alpha. Is there a second answer? Meaning, is there a second possible triangle? The way you figure that out is by taking your first answer and subtracting from 180. And that gives us 135.3 degrees. And then you have to look and see if that were to be another alpha value, would it work with the original angle that was given in the problem? Could you form a triangle with it? 135 degrees and 80 degrees, if you add those together, that's definitely too big, right? Because that's already bigger than 180, which is what the entire, all of the angles in the triangle have to add up to. So this is not going to work. So there's only one answer. Okay, moving on to the next one. Alpha is 48 degrees, A is 16, and C is 20. We could set up our law of sines again. Sine of 48 degrees divided by 16 has to equal sine of gamma divided by 20. And then cross multiply. So 16 sine gamma equals 20 sine 48. Divide by 16, that gives us sine of gamma is approximately, type this in, 20 sine 48 divided by 16 is 0.9289. Okay, to solve for gamma, we take the arc sine of that number. So arc sine of 0.9289 is 68.3 degrees approximately. Okay, so we definitely have one triangle, one answer for gamma. Can there be a second triangle? So is there a second gamma? We do is we subtract from 180 degrees, which gives us 111.7 degrees. Now compare that with the original angle in the problem, which was 48 degrees. If you add them together, is your answer less than 180? Because if so, then that means that this is a valid second answer for gamma. So if we add 111.7 with the 48, that is 159.7 degrees, which since that is less than 180, that means that this works. So there are two answers for this one. All right, last one. We're going to try to find beta. We would have sine of 30 degrees divided by 7 equals sine of beta divided by 16. Cross multiply again. You get 16 sine 30 equals 7 sine beta divided by 7. Let's type that in. 16 sine 30 divided by 7 is 1.1429. All right, you see something wrong with that? Is it possible for sine of an angle to ever equal 1.149 or 29? The answer is no, right? We can't have a sine value bigger than 1. Sine only goes, think about the sine curve, it goes from -1 to +1, -1 to +1, right? So this is not possible. And if you try to take the arc sine, it would just give you a domain error in the calculator like we saw before. Okay, so hopefully this sheds some clarity on how you can tell whether there's one triangle, which was this case, right? One triangle, two triangles, or no triangle.